Hi again. So this video goes with section 11. It's writing equations in point slope form. So we are going to be learning another equation for a linear function, which is y equals m parentheses x minus x1 close parentheses plus y1. And I know it looks more confusing, but I actually think that this is the better of the two formulas for a line that we're going to be working with. And if I had to pick one for you to know for the rest of your mathematics career, it would actually be this one over y equals mx plus b. And I'll explain why in a little bit. First, I want to show you where it derives from, because it actually is not just something new that somebody made up just to give you something else to know. It actually comes directly from the slope formula. So here's our slope formula. Slope is the change in y over the change in x. But notice that we took the subscript off of this point, the x2, y2. And the reason we did that is because we want to make that generic now. We want to make those variables. They could be any point on the line. So we're going to take those subscripts off and keep them as regular x and a regular y. If I wanted to get y by itself here, the first thing that I would have to do is multiply by this denominator. So on both sides, I would be multiplying by x minus x1. The reason we do that is because we want to be able to divide out the denominator. And that will leave us with m times x minus x1 equals y minus y1. The only thing that I did here is I swapped the position of m because we want to keep m in the front. Then if I want to get y by itself, I'm going to add y1 to both sides. And that's going to give me m times x minus x1 plus y1 equals y. And so that's how we can derive the point slope form. It comes directly from our slope formula. There are other books or other publications or other videos that might show it as y minus y1 equals m times x minus x1. And they leave all the y's on one side. And that's fine. You can learn it this way. So we'll make a note. You can learn it this way. But it must be solved for y to enter in your calculator or write as a function. So let's think about that for a second. We're not going to be able to write this as f of x equals if I keep the minus y1 over here. So that's why we like to get the y by itself, and we'd like to be able to use y equals m times x minus x1 plus y1. So this is the one that I think is beneficial to know. What are the important features? Well, m is still going to stand for slope. We're not going to change that. And x1, y1 is coming from an ordered pair. And that ordered pair is a point on the line. So it is a known point on the line. And that's what makes it so versatile, because I don't need to know a special point. I don't need to know the y-intercept. I can use any point on the line and I can create the equation. So that's one of the reasons that I like this formula better. The second reason that I like this formula is because it will magically convert to y equals mx plus b if you simplify it. And we're going to see that in the next few examples. So now we're going to switch to a worksheet that you have available in Blackboard. In Blackboard, it's the table for point slope form equations. I think it's something like that. And we have to fill in the information given this equation. So given these equations, we need to be able to extract this important information. So first, let's remind ourselves what point slope form is. So y equals m times x minus x1 plus y1. I'm going to directly compare the values that I see in each equation to the generic one so that we can just see what's in place of what. So in this first example, 3 is in place of m, 9 is in place of x1, and 2 is in place of y1. So that's going to allow us to answer these questions. So first, it's asking for the slope of the line. Well, 3 is in the position of m, and so my slope is going to be 3. Then it's asking for one point that we can spot on the line. Well, that would be my x1, y1. In this example, my x1 was 9 and my y1 was 2. So I know the point 9, 2 will be on the line. The last column here is asking for us to get this in slope-intercept form. So that's going to require a little bit of algebra. So first, I'm going to rewrite the equation, except I'm going to write it as y equals. So y equals 3 times x minus 9 plus 2. The first thing that I need to do to simplify this is to distribute the 3. So that's going to give us y equals 3x minus 27 plus 2. Then I have like terms, negative 27 plus 2. And so I'm going to get y equals 3x minus 25. And look at that. It magically turned into y equals mx plus b, or slope-intercept form. So that's another reason that I highly recommend knowing this formula. All right, let's continue. I'm going to leave the next one for you to do. Okay, so now let's do the g of t. Do you think it matters that the input variable is now t? Not really, okay, as long as you know that that's the input. So if I want to compare this, and because we're getting further from the top, I'm going to write it directly above x minus x1 plus y1. Okay. Look at where the positions match up. So 1/2 is in place of m. It doesn't matter that this is called t instead of x. It doesn't make a difference. My x1 is 8. In this case, it would technically be t1. Okay, that again doesn't make a difference. So that's in position of the x1. And my y1 is negative 3 this time, because this is supposed to be plus y1, and I have a minus. If it's a different sign, then I must have to take the opposite sign. So this is just like saying plus negative 3. Those are the same exact thing. And so y1 must be negative 3. So now we can fill in the columns. The slope here is going to be 1/2. One point that we know is on the line is going to be 8, -3. And now we have to simplify this by distributing. So let me copy it over here. It's y equals 1/2 times t minus 8 minus 3. Distribute the 1/2. So this is y equals 1/2 t minus 4 minus 3. And this becomes y equals 1/2 t minus 7. So now I can see that in y equals mx plus b form, I would have y equals 1/2 t minus 7. Okay. Now let's do the next one. We're going to do this f of x. F of x equals -8, parentheses x plus 1, and then plus 7. So again, let's write the formula right above it so I can do a direct comparison. Okay, so what are in all the important positions? -8 is in place of m. This is supposed to be x minus x1, but I have a plus 1. So if you think about what we said for the example right before this, this must have been the opposite sign. So let's actually write out down here what it would have been. If this had been shown as x minus -1, that minus minus is how they got the plus. That's where the plus came from. And so -1 really is in the position of x1 because it's minus a negative, and that's where the positive is coming from. As a shortcut to this, just look for the opposite sign, okay? If the sign was supposed to be minus and you notice a plus, then you put the opposite sign, okay? So now let's fill in what we know. The slope here is going to be -8. That's in position of m. A point that we know is on the line is going to be -1, 7. Again, why is it -1, 7? Because this is supposed to be minus x1. So the only way that that could have happened is if it was x minus -1 to become a plus. Okay, so again, opposite sign. And then last but not least, we have to simplify this. So this is going to be y equals -8 times x plus 1 plus 7. So this is y equals -8x minus 8 plus 7. And then combine like terms, and it's y equals -8x minus 1. And that would be the equation in slope-intercept form. I'm going to leave the rest for you to do. I hope this makes sense. So if you have any questions about this, please don't hesitate to ask. And I hope you enjoy the rest of your day.